Hey folks, so in this video, hey folks, so in this video, what I want to start doing is implementing our stack, but now with a list. So the first thing we need to do is basically set the scene. So we need to add another member variable to our stack. So before we had an array inside, now we need to somehow store a list. The way we store a list is basically have a reference to a node in it, to what we call the head node. So think about creating basically this extra variable here, and I've already outlined it here. Private linear node item type head. So this line of code here, what it is basically a line of code I can add to my stack class to give it a new member variable called head, right? Which is of type linear node. Linear node, of course, being the node we implemented in a previous video, right? So we're saying, okay, I know about a node, right? And this node is going to store item type. And item type is actually going to be the generic that we use in the definition of our actual stack itself, right? So this variable as a whole, what it's doing is this is kind of a replacement for having a variable called data that held that array that contained all the pieces of information that my stack had inside of it, right? So this is a way we can just store a stack inside instead. Now, head is the most typical name for this. You may also hear people say something like head, right? Those are kind of very typical names. For us, I'll stick with head just because it's familiar. Well, head, front, here, even top, right? All those would be reasonable names, right? Maybe even top would be a slightly better name. For now, though, we'll just stick with head. Okay, the idea is that this is basically a variable that will be pointing to that topmost element, right? So maybe it's null because there's nothing there, or right, if there is an element there, it's going to be pointing at basically that topmost element, that topmost node, right? That'll be our basic idea. Now, at the beginning of the day, we probably do want to initialize this thing. We're going to have to set equal to null, perhaps in the constructor, just to indicate that I don't have anything that already exists there, right? We'll have to kind of put that on our mental to-do list. All right, so first step here, basically in our class, right, is we'll add this line of code to introduce this new member variable that stores the head of my list. So what does our code look like then? It looks something like this. So this is now our linked stack, and you can see over our generics, we implement the stack interface as well. So we are our true stack now at this point, right? And inside, right, you have the variables, right? So I have here, I forgot that I changed it to top in this slide. So this is our top variable, the one we've been talking about over here, right? So we have that, that's the start of our linked list. And then we have the end variable. I'll come back to that in 1 second. And our constructor, of course. And our constructor array is actually a little bit simpler than the array-based approach, because in the array-based approach, we had to actually do the keyword new. We had to go to the system, ask for memory, create basically a brand new allocation for that array, and then store that in our local variable. So here it's a little bit simpler because we just set basically top equal to null, because hey, at the beginning of the day when I create a stack, there's going to be nothing stored into it, right? So it makes sense for it to be null. Now we also have this variable called n, which is maybe also familiar, right? There was another variable called n that was in a previous implementation, our array implementation. Although obviously, right, we used n as an index into the array, which we don't really need here because I don't have an array anymore. So what might I use this particular n variable for? Take 1 second and think. Okay, so n has a pretty obvious use. N is basically a variable I can use to store the number of elements in the array, right? So in the list, right? It's hard to figure out, basically just looking at the head of a list, how many things are in there. Because in order to do that, I need to look at the first one, then go look at the second one, third one, fourth one. I need to go through and look at each one in turn and count them up. It's more convenient if I have one variable that I just use to track over time. These are how many things I'm storing, right? So you can maybe imagine in push, we'll have n++, and pop will have n minus minus, right? It'll be this variable that I maintain over time, and which records the number of items that I've added to my stack so far. Okay, so so at this point we've set the scene, right? We have basically our two variables we care about, right? Our one for the size, our one for the head node. Now it's time in the next couple of videos to start looking at actually implementing push and pop.